Okay, so here are our sum and difference identities, and you have these on your formula sheet. And so one of the first things they're going to ask us to do is to find the trig ratio for some angles that are not unit circle values. So what we need to do is find unit circle values that will give us 75. So pretty clearly, that's 30 plus 45, right? So then I would need to look at my formulas and see which formula matches. So there it is. So then I can split up the sine of 30 plus 45 into how that formula reads. So sine 30 cosine 45 plus cosine 30 sine 45. Then I need to look at the ordered pairs for 30 and 45. And then it's just plug and chug, right? We're going to plug the values in, and there we go. So when we have a angle measure in degrees, pretty easy. Let's look at this one where we have radians. So here we need two unit circle values that will either add or subtract to give us 7 pi over 12. Well, here are our normal unit circle values, right? Pi over 6, pi over 4, pi over 3, pi over 2. I could keep going if I needed to. And so we need to come up with the equivalent fraction for each of those to be over 12. So that's 2 pi over 12, 3 pi over 12, etc. So then looking for which of those two will either add or subtract to give us 7 pi over 12. We can pretty clearly see the two it is. And then in our formula, we won't use the 3 pi over 12 and 4 pi over 12. Instead, we'll use the pi over 4 and pi over 3. So we can rewrite the cosine of 7 pi over 12 as the cosine of pi over 4 plus pi over 3. And then you can see we'll use that first formula there. So then we can rewrite again using the formula. And then there are ordered pairs for pi over 4 and pi over 3. And then we're just plugging in. Now you might notice that this answer looks a lot like the answer that we just got on the last one. Well, if you think about it, the only values we really have to work with are root 2 over 2, 1/2, and root 3 over 2, if we're talking about sine and cosine. So it's not going to be unusual for all of our answers to look really similar. So be really careful with your signs. This is the tangent of pi over 12. So we have the same situation where we need to look at our unit circle values and the equivalent fractions over 12. And nicely, we just did that. So we know it's going to be the pi over 4 and pi over 3. So I would rewrite and then identify which formula we're using, plug it all in, look at my unit circle values now. So pi over 4, there's my ordered pair, but the tangent then of pi over 4, because for this formula we need tangent, the tangent of pi over 4 is 1. And then for pi over 3, remember it's y over x, so it's just going to be root 3. And then I plug into the formula. Some of the tangents do get a little bit icky if your tangent is a fraction. So just be careful and remember that you can rewrite that as horizontal division if you need to. The second thing they ask us to do with sum and difference, is find the exact value here. And so to do that, we're going to look at which sum and difference identity matches that problem. So when I look at it, I can see that it matches the sign of a minus b. So if I rewrite it, so I'm kind of going the opposite direction than what we just did, right? If I rewrite it, I get the sign of 180, which there's my ordered pair for 180, so the sign is 0. Okay? And then here it's the same thing again. We are looking for the whatever formula this is to make it simpler. So I'm going to look and I can see it matches with that formula. So I'm going to rewrite it. And that's the tangent of 12 pi over 8, which simplifies to the tangent of 2 pi over 3. So 2 pi over 3 has the ordered pair 1/2 root 3 over 2. But 2 pi over 3 is in the second quadrant where x is negative. And so the tangent is negative root 3. Okay, so those are the first two things they want us to do with sum and difference.